Hello, friends. It is Monday, October 12th. Once again, we are going to be talking about integer soup. Last week, we talked about adding integers, and we had a little story about chefs adding hot and cold cubes to their soup to raise or lower the temperature of the soup, and how that translated to adding integers. Today, we are going to be talking about a new idea. So let's go ahead and get started. So, yesterday, or actually last week, we talked about some amazing chefs in a far off land who cook up wonderful soup. Sometimes the chefs have to adjust the temperature of soup that is too hot or too cold. How does adding hot cubes or cold cubes change the temperature of the soup? Well, we discovered that, hopefully this works. Adding hot cubes increases the temperature of the soup, and adding cold cubes decreases the temperature of the soup. The temperature of the soup in this cauldron is -8. How could we increase the temperature of the soup? Well, we can do that by adding hot cubes to the soup. The temperature of the soup in this cauldron is -8. Is there a way to increase the temperature without using any hot cubes? That's supposed to say without. Let me fix that. So how can we increase the temperature of the soup without adding hot cubes? Well, we can do that by taking out cold cubes. So if we can subtract cold cubes from the soup, we'll be able to raise the temperature of the soup. So I think you're probably seeing where we're going. We are going to be talking about subtracting integers. So the temperature of the soup in this cauldron is -8. The chef wants to increase the temperature by 2 units, but there are no hot cubes available. Is it possible? Well, absolutely it's possible. We can take out 2 cold cubes in order to increase the temperature. So if the temperature of the soup is -8 and we take out 1, 2 negative or cold cubes, we can increase the temperature of the soup. Temperature of this soup is -10. The chef removes 6 cold cubes. So I've used our counters like we did when we were adding integers. I put 10 negative signs here, and if we remove 6 of them, 1, 2, 3, 4, 5, 6, what is going to be the temperature of our soup? Well, of course, it's going to be -4 because we took out 6 of the cold cubes. This soup, the temperature is +5. If the chef removes 4 hot cubes, 1, 2, 3, 4, the temperature of our soup is going to be +1. So again, we can use our counters to subtract integers just like we used counters to add integers. Now, there's going to be a little twist here. So, if the temperature of the soup in this cauldron is 12 degrees, 12 +12, the chef removes 7 hot cubes. So we've got 1, 2, 3, 4, 5, 6, 7. We are left with 5 hot cubes. So the temperature of our soup is going to be +5. Now, what happens if the temperature of our soup is -9, which I've shown here with our negatives? We've got 9 negatives, and we want to take out 5 positives. Well, Ms. Suhan, there aren't any positives to take out. We can't take them out because there's nothing there. So what we need to do is add what we call our zero pair. Remember, we talked about this last week, and we said if we had a negative and a positive, that equals 0, right? So if I add a negative and a positive both to the soup, that doesn't change the soup. We still have the temperature is -9. So we have 10 negatives and 1 positive. So our temperature is still -9. So if we add enough zero pairs to our soup to make it so we can subtract 5 positives, what do you think is going to happen? So now I've added 5 zero pairs. The temperature of my soup has not changed because remember, one negative and one positive cancel each other out. So I've added 0 5 times. But now I have 5 positive cubes or hot cubes I can take away. So there's 1, 2, 3, 4, 5 negatives that I've taken away. And what am I left with? Well, I'm left with my original 9 negatives plus an additional 5 negatives. So my total temperature of my soup is now negative 14. That's a little confusing, so we're going to practice that a little bit more. So here's another example. We have positive 6, which I've represented with our 6 plus signs, and we want to subtract positive 4. So we have 4 plus signs that we can take out. Delete, 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 and the temperature of our soup is now 2, positive 2. Here is another example, negative 7, which I've shown here with our 7 negatives signs. We are going to take out 7 negatives. So we're going to delete those. We're going to subtract those cold cubes. 1, 2, 3, 4, 5, 6, 7. So our temperature is now 0 because we have no negatives or positive left. Let's do another example with adding 0 pairs. I've got 3 positives right here, and I want to take out, I want to subtract 3 hot cubes. I want to subtract 5 hot cubes. I don't have 5 hot cubes. So if I add some 0 pairs, there's 1 0 pair, and there's 2 0 pairs. Remember, that doesn't change the temperature of our soup because a negative and a positive cancel each other out. I just added 0 twice. So now I have 5 positives and 2 negatives. So now I have enough positives to be able to subtract 5 positives or 5 hot cubes. So I'm going to do that right now. So I had my original 3 hot cubes. I added 2 0 pairs so that I would have enough hot cubes to take out. So now I'm going to subtract those hot cubes. 1, 2, 3, 4, 5. And I'm left with 2 cold cubes. So my answer to positive 3 minus negative or positive 5 is going to be negative 2. All right. This can be a little confusing, so we're going to definitely practice this some more. But what happens to the temperature of the soup when the hot cubes are removed? Well, when we remove the hot cubes, the temperature of our soup goes down when we remove the hot soup cubes. It cools off. All right, so if we look at that on a number line, here's our soup temperature, and we subtract hot cubes, we're decreasing the temperature of the soup. The temperature goes down. We're moving to the left on the number line. And what happens to the temperature of our soup when cold cubes are removed? Da, 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 da. The temperature of our soup goes up when cold cubes are removed. It gets hotter. So again, on the number line, if our temperature of our soup is right here and we take cold cubes out of the soup, the temperature increases. So we're going to move to the right on our number line. So what are the ways a chef can use hot cubes or cold cubes to increase the temperature of the soup? Well, we can what are the ways a chef can use hot cubes or cold cubes to increase the temperature of the soup? If we're trying to raise the temperature of the soup, we can either add hot cubes or subtract cold cubes. Either one will increase the temperature of our soup. And if we're trying to decrease the temperature of our soup, adding cold cubes or subtracting hot cubes are both ways to decrease the temperature of the soup. So let's take a look at some more practice problems. I've added some counters on here, so you can do this on your packet that you got in class on Friday, so you can follow along. But I am going to start out with positive 9. So I've got my 9 plus signs here, and then I'm going to subtract, so I'm going to delete positive 5. So I'm just going to take out 5 plus signs, 5 hot cubes. 1, 2, 3, 4, 5. So the answer to positive 9 minus positive 5 is 4. And of course, that's something you learned back in elementary school. We know how to subtract positive numbers, especially when the first number is bigger. But let's take a look down here at this example where we've got a plus 6 minus a positive 10. How do we subtract, Miss Duhan, a bigger positive from a smaller positive? Well, again, we have to add 0 pairs. I know this gets a little confusing, but we started out with 6 positives. Now we want to add more positives, but doesn't that change my original number? Well, no, because we are adding 0 pairs. So it does not affect anything. We still have positive 6. I've added 3 zeros. I'm going to add 1 more so that we can subtract and find our answer. So we've got our original 6 positives, hot cubes, and I've added 4 0 pairs in order to be able to subtract the 10 hot cubes or 10 positives. So we're going to subtract them now. We're going to take away 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we are left with negative 4 or 4 cold cubes. So our temperature decreased. All right, let's take a look at the next problem moving down. We have negative 5 minus negative 12. Oh, that's going to be a tough one. We have 5 negatives or 5 cold cubes here, and we want to take away 12. Well, we don't have 12 negatives or 12 cold cubes to take away, so guess what? We're going to have to add 0 pairs to be able to take those away. So we're going to add 1, 2, 3, 4. Do we have enough cold cubes yet? Nope, we're trying to get to 12. So we got to add another couple sets of 0 pairs until we get 12 negatives that we can subtract. So we're going to have to do this 1 more, 2 more times. And now we have 12 cold cubes or 12 negatives to subtract. So let's look at this again. We started out with our original 5 negatives. We added 7 more 0 pairs in order to be able to subtract or take out 12 cold cubes. But remember, we are not, by adding these 0 pairs, we're not changing our original number. So let's go ahead and subtract those cold cubes or those negatives so we see what we have left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we subtracted our 12 cold cubes and we are left with 7 positives. So this is 1, 2, 3, 4, 5, 6, 7. So positive 7. All right, let's go ahead and tackle this negative 10. We're going to subtract positive 5. We don't have any positives to subtract. So guess what? We got to add 0 pairs again. So here is a 0 pair. Here's a 0 pair. Here's a 0 pair. And I think we need one more 0 pair. All right, so now we have enough positives to subtract our positive 5. So we started out with a negative 10 or 10 cold cubes. We want to take out 5 hot cubes. We didn't have 5 hot cubes to take out in our original soup, so we added 5 0 pairs, and now we can subtract those. 1, 2, 3, 4, and 5. So now we have all these negative or cold cubes And let me just organize them a little bit so we can see what we have left. So we have 15 cold cubes, or 15 negatives. So negative 10 minus positive 5 is negative 15. Let's take a look at the next one. Negative 6 minus negative 2. So we have 6 cold cubes, 6 negatives here. We're going to take out 2 negatives, delete, and that leaves us with negative 4, or 4 cold cubes. One more problem here. We have positive 8, so 8 plus signs, 8 hot cubes, and we want to subtract 7 cold cubes. We don't have any cold cubes to subtract, so guess what? We're going to come over here to our 0 pairs and add them so that we can subtract. Seems strange to add to be able to subtract, but when we don't have any negatives to take out of the soup, or cold cubes to take out of the soup, we have to add some 0 pairs to be able to take out those. No, I don't want to do sticky keys. To take out those negative or cold cubes. And one more. All right, so here we go. We started out with our original 8 positives, which is what our problem said, and it said we need to take out 7 cold cubes. We didn't have any cold cubes, so we added 7 0 pairs. That way we didn't change the temperature of the soup, but now we have enough negatives or cold cubes to take out. So let's go ahead and delete those or subtract those cold cubes. 1, 2, 3, 4, 5, 6, 7, and that leaves us with all these hot cubes. So now the temperature of our soup is positive 15. All right, so can we write some rules for subtracting integers? Subtracting integers is not an easy thing to understand. With adding 0 pairs, it just kind of goes against what we've always been taught in math. So I'm going to help you out by giving you the secret sauce, giving you the secret formula for subtracting integers. When you are subtracting integers, you must add the opposite. And let me show you an example of that. If we go back up to the problems that we did in the previous slide, you'll see what I mean. So let's take a look at this one. Remember, we had to add a whole bunch of 0 pairs to this in order to be able to subtract 5 positive or hot cubes. Well, if we had just changed this subtraction sign into a addition sign, and then we had taken this addition sign or positive sign and changed it to the opposite sign, a negative sign, we would see that we are just going to add the opposite. So negative 10 plus negative 5 is negative 15. That's the cool thing about subtracting. If you've got a really good handle on adding integers, then you can do subtracting, because all you're going to do when you're subtracting integers is add the opposite. So here's another example. Negative 6 minus negative 2, let's add the opposite. So we're going to change the subtraction sign into a addition sign, and we're going to take this negative 2 and turn it into the opposite number, a positive 2, and we're going to add. Negative 6 plus 2 is negative 4. See, we matched what we already did down here. And then one more example of that, if we add, if we take positive 8 or 8 hot cubes and subtract negative 7. Remember, we had to add a bunch of 0 pairs in order to get enough negatives to subtract. Well, if we had known the rule before, we could have just added the opposite. So we can take the subtraction sign, change it into an addition sign, take the negative 7 and make it at the opposite, which would be positive 7. And now we have positive 8 plus 7 is 15, which is what we got when we did all that 0 pair with the counters. So that's really the little secret sauce trick for subtracting integers, is just to add the opposite. So Remember this, when subtracting integers, you must add the opposite. It makes life a lot easier. So hopefully you will be able to go ahead and do your homework for today. I would highly recommend that when you're doing your subtracting integers homework packet that I gave you on Friday, that you use the counters and do the subtraction, the plus and minus signs that we did in the presentation here, and then check it by adding the opposite and following that rule. If you have any questions, please send me an email. Hopefully you will be able to do this pretty easily now that you know the little trick. So have a great day.